Well, I want to talk about some weather research. There are a lot of great universities all across the country that do a lot of meteorological research. And I participated in a weather conference where I got to see firsthand some of the research that's being done. And this was specifically in New York State from SUNY Oswego, and it had to do with lake effect snow, and it could actually relate to us here in southeastern Wisconsin. So let's talk about this here. Now, as we zoom in to New York State, you can even see lake effect snow bands here. This is a big region for a whole lot of lake effect snow every winter. And there is an area here called Tug Hill that is notorious for a whole lot of lake effect snow, and here's why. Because the elevation rise goes from about 250 feet to just over 2,000 feet. So you get that wind blowing against that upslope flow, creating that heavy lake effect snow and really enhancing that lake effect snow over Tug Hill. So this is often the epicenter for high lake effect snow. Now, in addition, it contains a very large wind farm, which is interesting because this research study that was done by Dr. Scott Steiger and his students at SUNY Oswego had to do with lake effect snow bands and particularly lightning within those lake effect snow bands and what could be causing that lightning. Because as we know, here in the Wisconsin area, thunder snow can happen, although it's relatively rare, and it's pretty interesting when you're talking about lake effect snow. So they did a big study and that incorporated portable Doppler radars, for example, and a whole bunch of different equipment to try to figure out what's going on when they get lightning strikes within these lake effect snow bands. So Tug Hill had the most lake effect lightning because of the large wind farm. So think about that here for a minute. So when you get lightning, lightning forms when you have a separation of charges in the clouds. Now, typically in the spring and summertime, those are cumulonimbus clouds. So you'll get ice in the top part of the cloud, and you'll have water in the lower part of the cloud, and then you'll have a positive charge developing on tall objects like trees and power poles, and that can lead to lightning strikes. But what they discovered in this study is in the wintertime, well, the clouds, first of all, are not as thick, right? So lightning is relatively rare, but you can get a separation of charges within these clouds, in part because of graupel, or those soft snow pellets that sometimes we see in the Wisconsin area. That can interact with the ice in the clouds and cause a separation of charges, meaning a positive charge emanating from the wind turbines, negative charge coming from the base of the clouds. And it's interesting because those clouds the bases are relatively low in comparison to, let's say, summertime type thunderstorms as well. So again, the dynamics of the storms are different in the wintertime than in the summertime. But what they found here is that it was actually the wind turbines that could be initiating the lightning, because they were able to look back and see that the lightning climatology, or the lightning frequency, changed. The lightning landscape, if you will, changed after the wind farm was built. So that means that these wind turbines were playing a role in increasing the frequency of lightning within these lake effect snow bands. Interesting, right? So why do we care about this here? Well, we have a wind farm, right, in southeastern Dodge County, just east of Iron Ridge. We also have tall downtown buildings as well. We also have Holy Hill as well, which is a very tall area. So the question that, as a meteorologist, that I have going forward is, now granted, we don't often get a lot of lake effect type snow bands. That's more on the other side of Lake Michigan. But anytime we get banded snow, be it lake effect or what we would call synoptic or mesoscale snow bands within a storm system itself, sometimes we get thunder snow, right? And I'm going to be very interested now to see if any of our tall structures, including our TV towers in Estabrook Park, may play a role in that. So where do we see the lightning striking when we have winter weather? Again, it's different than a summertime scenario. So it's going to be very interesting to see. And now one of the other interesting parts of this study is it's not only that the lightning coming down from the cloud, but it could be induced from these wind turbines themselves. So it could actually start at the top of the wind turbine and then go up. We've seen that happen before as well. So again, a very interesting lake effect lightning study, and I really want to give all the credit to Dr. Scott Steiger and his students for doing all of this research, because it's something now that here in Wisconsin, we're going to be looking at to see if any of our tall structures may play a role in winter lightning strikes.